Good evening, guys. I just want to start with the story. In the year 2001, well, that's not when I got married. I was still a happy-go-lucky young man at that point. So in the year 2001, he landed in front of me actually, or ahead of me, and it was a contracting company. The construction field was such a alien subject for us. In fact, when I was called for the interview, I thought HVAC stands for high voltage alternating current. In fact, that's the definition I had in my mind. So this guy landed in Saudi ahead of me, and then the first task when we enter into that company, the first task we are given is to study the BS standard 5839. So that's where our learning starts actually. That's how the company had formatted their graduate entry program. So he started off with the fire alarm system design, and we had a very, very tough boss, still a mentor to me. So he made us actually learn things. And the way he made us learn things, I think it was absolutely fantastic. So this guy, he went on with the fire alarm system. The code itself, probably 50, 60 pages at that point of time. He went through the code, and then probably after he finished reading through the codes, he was asked to do the design of a building. Right. So our boss turned up and said, "Okay, now you have read the code. So take a building and do the fire alarm design for the building." He started doing it immediately, actually. So he had a A3 size paper and he started designing the fire alarm system. And our boss, he had an habit of just getting up from the table and just move around the office to see what the guys are doing. So when he passed by, just peeped into his table, he saw some weird building, okay? So he was there in the company for quite a long time, and in fact, most of the air bases in Saudi Arabia, he would have had his hands on. So when he looked at the building, he didn't realize what it was, which building was it. He has never seen in so many years in that company. So out of curiosity, he asked him, and he is a tough person, okay? He doesn't smile in the office. So he asked him, which building is that? This guy, he said, we all speak Tamil and we generally speak Tamil in the office. He said, "Sir, இது akka வீடு." Meaning it is his sister's house. Okay, so our boss never gives complete information. So he gives cues actually, and then you will have to take the lead from on there. So he meant he had actually a bunch of A3 binders. So the A3 binders for various buildings will be there from different stages. What he meant was, you take one of the buildings from the binder and start doing the fire alarm system design for that. So obviously we are quite new to that place and he didn't have the idea. So he started with his sister's house. So for us, whenever I talk about fire alarm system, the first thing which comes to my mind is Akka Veedu. Okay, so let's begin our presentation for the Akka Veedu's system design, right? Right. Look, in the presentation, it is not going to be like a tutorial for everyone to that after the presentation you can go about and start designing the fire alarm system. But I'm sure after this presentation, if I am successful, probably I'll put some questions in your mind. So when you go home and start your work on the next day, I believe you will start with several questions. Your way of looking at the drawing and the design will have a little bit of impact from this presentation. If I can do that, I believe this is going to be a wonderful presentation. So we will talk about some fundamentals of fire alarm system, and then the most important thing is the overseen elements in the fire alarm system design. I'm sure most of you would have started as an electrical engineer over here. Whenever you started your career, I'm sure you would have started with the fire alarm system design. And obviously everyone would have started with placing all the detectors, manual call point, sounders, strobe, whatever. So that's how you would have started. Everyone would have come across that. So we are not going to touch upon how to place the detectors, what should be the spacing, where you should place, not all those things. But what all the components will be there, and the overall operational philosophy of the fire alarm system, which is the most important part, and it is generally overlooked in the design. So I don't want to read through all of them, but let's go one by one. So To start with fire alarm system, what do you think is the purpose of any fire alarm system? What does the system serve in a building? And please give some answers. I can't be talking all the time. I want the things to be a little more interactive, because if you see my slides, it will be very plain. You will not get most of the information. I thought this will just give me a cue to go into the presentation, and then we will just have a discussion. This is not a tutorial, by the way. So let's start with that. So what do you think is the purpose of a fire alarm system? Early detection. It alarms, yes. So that is notification. What else? Yes, there are further actions. Yes, that's what I'm leading to. So what are all the actions you think it will take? Safety alert, yes. Sorry?
Neighbor's cooking has activated the alarm.
Neighbor's cooking has activated the alarm, right? Okay. So what follows after that? So those are the important things what the fire alarm system should serve actually. So as I've written down, first thing is the identification or the initiation. So when there is a fire, the system should be able to identify the fire or the smoke, and then it should be able to alert the occupants in the building. And the final thing is, the most important part of the fire alarm system is, it should be able to safely evacuate the building. When we talk about evacuation actually encompasses a lot of system. It is not just about passing out the message to each of the floors and the occupants that the building is on fire, or your floor is on fire, you will have to evacuate. That's not just the only purpose of that. So the fire alarm system also talks to several other systems, so that it makes sure that when the people are alerted, they could safely evacuate the building. So that is the most important thing the fire alarm system does, apart from initiating the alarm and then notifying the occupants of the building. So in the forthcoming slides, we will get to know what all the system it actually talks to and why is it important. So moving on to the system components. So as I said, there are broad categories of or the purpose of the fire alarm system. So likewise, I just categorized it. So the first set of devices, the initiating devices, as you could read, it is detectors, manual call points, and then other systems via IFUs. I'm sure IFUs, every MAP engineers here will know the interface units. So for me, the fire alarm, I like fire alarm system a lot. Designing a fire alarm system is so fascinating, particularly if you're in contracting field. You will love doing it because it is so challenging. In consultancy, it is about just placing the devices. Your drawing is done most often. The schemes that we use are age-old scheme, the typical schematics. Design is done. Generally 1 week, 2 week, the fire alarm system for the entire tower is done. But actually, that there is much more to the fire alarm system. So when I'm saying the other systems via IFUs, can you think about any other system which can initiate an alarm in the building other than the detectors, not the traditional or the typical initiating devices you can think of? Fire pumps, but yes, fire pump in a way, yes. Sorry, I can't hear you. Thermal camera. Sorry, no, that is not actually integrated with the fire alarm system. LPG system actually is interfaced to the fire alarm system, but LPG system doesn't give you initiation of fire, or it doesn't give you a signal of fire. Smoke exhaust fans, again, they also fall in the same category. They are actually some system which are actually responding to the fire alarm. But what else can initiate or send a signal that a fire is initiated? Elevator is, again, they respond to the fire alarm from the system. The question is, which other elements actually give a signal that this is a confirmed fire? Yes, that's the obvious one. Sensors falling under the detectors category. Zone control valve. So how do you think a zone control valve actually gives a signal to the fire alarm? Exactly. So when when a sprinkler bursts somewhere in the building and the water starts flowing in that sprinkler pipe, the flow switch actually captures that. The flow switch could sense that the water will generally remain stagnant in the sprinkler pipes, right? So when the water starts flowing in that, the flow switch gets activated. The flow switch is actually interfaced through the interface unit to the fire alarm system. So the fire alarm system comes to know that there is a flow in the pipe, so obviously there is a confirmed fire. So that's one fire pump. So I guess that makes the whole thing. And then the next category of devices are the notification device. Obviously, you can all tell me that sounders, evacuation speakers, strobes. I forgot to mention I have just mentioned the standards just in case if you want to refer to. But as I said, I will not be dwelling much into the standards and the codes here. Right. The other component that I wanted to talk about was the control panel. So what are all the control panels you have come across in the fire alarm system? Again, I've listed here. So probably because of the time, I'm just rushing a little bit. So the important part is how do we actually approach the Akavedi design? So when you start, even before you get into, locating all the detectors and all the devices, take a step back, look at the project. You have to understand who are the stakeholders, how the project is divided. For example, if a project has got 5-6 towers, they are sitting on a common podium, then you should understand who are the asset owners, how the buildings have to be operated, whether the client is going to sell each of the towers or is he going to own all the towers. What is the vision of the client? That is more important, and that is not just for the fire alarm system. For any system or any services that you're going to design, that should be a starting point. So when I say overarching philosophy, this is what I meant. So if there are different assets in a building, in a project, once you understand that if the assets are going to be operating individually, yet the owner wants to have overall control or overall monitoring as well, then you would end up in providing individual systems for each of these towers or each of these assets, and then finally there will be one integration that will be happening across all the assets. So that should be a starting point even before you start getting into the drawings. The next one, which is very important, is to locate the fire command center. Again, for locating the fire command center, the same thought process, whether each of the building are going to be operating separately. In that case, you will have to end up in having fire command centers in each of the buildings, or else you could have one fire command center which is going to act or which is going to integrate all of them, and when the firefighters come into the building, they can get into one fire command center and they can actually operate or control all the buildings from there. And then you start thinking about where do you locate the detectors, sighting of the detectors, what kind of detectors are required, where should you locate. Then when you start going beyond, when you start locating the manual call point, look at the search distance. You start from locating the manual call points at all the exits from a floor or from the building. Every exit point should be covered with manual call point. So once you have done that, then you have to check the search distance. Because I started with BS, always my thought is search distance is 30 meter, NFP allows you to 45 meters. Search distance is actually the distance I will have to cover to reach any manual call point which is around me. So that's the search distance. It cannot be a straight line. Sometimes it has to go around the core and then maybe through some alleys, and also you have to take care of that. And based on that, if the search distance is exceeding the 45 meters criteria, then you will have to add additional manual call points in between. And then you will start sighting all the sounders, strobe, sighting of voice evacuation speakers, which is the VE speaker, sighting of fireman telephone outlets, IFUs, and then think about what are the other systems which are going to contribute to the fire alarm system. So if you remember the purpose of fire alarm system, the most important part I said was the evacuation. So when you think about evacuation, there are several other systems which will come to play. So fire alarm system will have to talk to all of them. So when you think about integration, think about all other system. Your mechanical guys, they will know all other FLS system, and everything should be integrated to the fire alarm system. So one note I've added here is for the voice evacuation speaker. So the UI fire life safety code, it mandates that fire alarm voice evacuation system should be provided for any high rise tower, the definition being any tower more than 23 meters. So every building which is beyond that has to be having a voice evacuation system. Any places of high occupancy like malls, assembly area, hospitals, schools, they should be having voice evacuation system. Right. Out of this, just one question to all of you. What do you think is the purpose of firemen's telephone outlets? We do that quite often everywhere in the elevator lobbies. If there are refuge areas, if there are lift machine rooms, we end up in providing firemen's telephone outlets. So, what do you think is the purpose of that?
Persons at the fire zone to evacuate the person, to call the people.
Yes, you are partially there. Any other answers? It is actually an outlet, telephone outlet actually. It is not a speaker or anything. It's just a telephone outlet, but it is fire rated. Yes, telephone jack. Exactly. So I just repeat what you just said. So the fireman telephone outlets are provided in various areas of the floor, just for the firefighters. So when they come in, so they will actually grab a handset from the fire command center. So the two-way communication system, the firefighters telephone system that we provide in the fire command center, it will always have at least 5 to 6 handsets. The project specification will tell you that. So they will grab one of the handsets, go around the floors, the fire affected floors, wherever they want to, and if they want to communicate with the fire command center, they will not be using mobile phones or anything, but this is the only tool that they are going to use it to communicate with the fire command center. So that's the main purpose of it. One purpose I just recollect that I missed adding in the first slide about the fire alarm system. The system should also offer manual control or manual evacuation process. So when the civil defense guys, firefighters enters into the building, they will not let the building still working in the automatic mode. So they will actually take control of the whole building, and then manually they will try to evacuate the people from the building. So for that, we have the smoke control panel. So the other purpose of fire alarm system is to allow for manual evacuation of people as well. Right. So the next item is voice evacuation system. I'm not going to go deep into that, but just the most important things when you design a voice evacuation system is at least 63 dB. Correct me if I'm wrong. 63 dB should be the minimum one, or 15 dB above the ambient noise is the design criteria. So when you are placing speakers across, so this should be your design criteria, and make sure that the speech legibility is so important. So your specification covers that. So when I talk about speech legibility, I don't know whether you would have come across situation where you are using sounders in some places and speakers as well. So when you imagine in this room, if you have a fire alarm sounder as well as a speaker, the sounder will keep on ringing actually. As soon as there is a fire, the fire is confirmed, the sounder starts, alarm. It starts alarming, and it's so noisy actually. And at that time, if someone is trying to broadcast a message to the people, obviously it's not going to be legible. The speech will not be so clear to the occupants. So for that reason, you should never actually mix these two notification devices in one. Is what I believe is most of the things, although are code driven, but if you apply just common sense, most of the things will make sense. Whatever is written in the code, you will get to know. I think he started his presentation with saying, what doesn't make sense? It will eventually make sense when you actually look for an answer and then search in the code or some standard, rather than reading the whole code and then you get started on the design. That may not help actually. So the other important things that I've just mentioned for your information is the human speech frequency that we are generally talking. The speech frequency of that speech is around 400 to 5000 hertz. The reason why I've included this is sounders, although they are also a speaker by means of the manufacturing, so they are also speaker, but their frequency response is quite, it's quite limited. It cannot duplicate all the voices that we produce. So the audible range is 20 to 20,000 hertz. The sounder will not respond to all the sounds that we actually talk. So that's why when it goes to voice evacuation and the background music, which we call as public address and voice evacuation, PAVA system, the important thing to watch out for that is whether the frequency range is of the speakers that they are using has got at least 400 to 5000 hertz. In fact, sorry, I stand corrected. For the PAVA speakers, it should be 20 to 20,000 hertz. So it has to have a complete flat range across all the frequency, audible frequency range, which is this 20 to 20,000 hertz. Okay, so I just want to do a small experiment to make this understand, but you guys need to cooperate for that. So I've written here the dB level increases by 3 dB when you double the power, and then it reduces by 6 dB when you change the distance actually. I just want anyone from the back just to say hi to me in their normal tone. Now, can you, with the same pressure that you would have given, can you try all of you together to say the same word again? Hi. You can see the difference, right? When the power has doubled, has gone multifolds, the legibility or the sound pressure level has increased so much. So that's how it is. And if you try to come closer to me and then call me, the sound pressure level actually increases by 6 dB if you actually half the distance. So when you start designing the voice evacuation system, although this applies as a thumb rule, because it gets what I've said is only 2 times actually, whether you're doubling or half the distance. When some distance is coming in between, you will generally need a software to actually calculate the sound pressure level. But as a thumb rule, when you start over, you pick up a speaker, you have to ensure that the speaker's output when you're standing nearby, it is not exceeding 120 dB. So that's your starting point. 120 dB, your ears will be deaf. So anything less than 120 dB, you can start off with. And then as you move, so the speaker's sound pressure level will be provided as maybe 89 dB or 90 dB at say 1 meter from the speaker. And then when you start placing it, as you move by another 2 meters, I mean double the distance, it halves actually. So 90 dB comes to 90 minus 3, right? 87 dB. I have given a small calculation also below that for the easy understanding. Next thing, speakers. So about the speaker circuit, so the standards and codes, they ask you to provide at least 2 speaker circuits per zone or per floor. So I don't think that needs a justification, because fire alarm system has to be foolproof, and losing one circuit cannot leave all the people stranded on the floor. So obviously for that reason, there should be at least two circuits, or you can actually loop them, which is called class A wiring. The next question, actually I should have asked as a question. I'm saying you shouldn't actually connect multiple floors in one of the speaker circuits. You don't have to be an electrical engineer to answer this. Why do you think this is so essential? Sometimes in smaller towers having small footprint, we may end up in having just 6 speakers in a floor or 4 speakers in a floor. Yet if the amplifier's speaker circuit can handle more than 10-15 speakers, yet we can't go to the next floor in the same circuit. Can you guess what could be the reason? No, dB level wouldn't have an impact if you go beyond. I'm specific about you cannot combine 2 floors in one circuit. You are almost there actually. No, you can manage that actually. If there are 2 circuits in the floor and 2 circuits in the next level, you can still not combine these 2 circuits, right? So it's not being, you're almost there, it's not being getting affected. So if you think about the process or the sequence which will happen, so when there is a fire in a floor, the only the floor occupants, the floor which is affected, those guys will be immediately evacuated. The floors above and below, they go in the alert mode, right? Speakers, if you connect all of them together, obviously you cannot send one message to one speaker in the circuit and another message to another speaker in the same circuit. So obviously this has to be separate so that you can have a phased evacuation. You never know when the firefighters come into the building, how many floors are they going to evacuate at the same time. So you have to give them the flexibility. So when you do the design, always think from the operational philosophy, and every code and every standard will fall in place. You can only go about referring to any doubts in the code. Rest of the things, common sense will do the job. This is the most important or the most interesting part of the fire alarm system. So the fire alarm system has to interface with all of them. So we'll go one by one actually, why and how do they do it. So let's ignore the BMS for a while. So I said access control system. Why do you think fire alarm system should be talking to access control systems?
When the fire happened, to evacuate the people.
Right. Correct. So if the doors are access controlled, all the people are locked inside the area. So obviously, safe evacuation from the building is one of the most important aspect of fire alarm system. So all the locks, the electric locks, will have to be de-energized so that people can go out. The next item, emergency lighting. So why do you think the emergency lighting needs a signal? Yeah. So see, the emergency lighting system is intelligent enough to come online if the normal power fails actually. But even then, to be double safe, the system sends a signal to the emergency lighting panel so that even the non-maintained lights, so we have maintained lights which are the exit and the non-maintained which are the emergency light sited elsewhere. So all the lights should come on so that the people can safely evacuate. So the escape route is eliminated. The next one is lifts. Why do you think the lifts will have to be connected to the fire alarm system? Right. Right. So if there are people who are stuck in the lift while the fire happens, so every building you go in, it will read that you should not use lifts in case of fire. So there will be people caught in the lift already. So for that reason, the lift has to go to the designated floor, the safe floor, whichever is noted. And then what happens if the same floor which is designated during the testing commissioning, for example, in most of the cases, I guess it will be the ground floor. So what happens if the ground floor is in fire?
Nearest above.
Right, so there will be one other alternate floor which is called. So remember, when you do the fire alarm system design and you are giving interface units for the lift control panels, every lift should have at least two interface units so that either it knows it has to go to the designated floor or the alternate floor. Right, so what's the next item? Can you read? Right, so which all the systems which form part of the ventilation? It's not smoke ventilation, just the normal general ventilation. And why do you think the ventilation system should be interfaced? FAHU. Yeah, exactly. So that's the most important point. So any fresh air that you are feeding to the floor is actually going to feed the fire. Oxygen has to be cut off from the floor. So that's the reason why all the FAHUs or the extract fans. So while the extract fan is running, it will try to pull the fresh air from some other area. So that system has to be cut off. So all this actually, if you think about it, all comes in the category of safe evacuation. And then the next item is MSDs and MSFDs. So what do you think is the purpose of MSDs and MSFDs and why they should be integrated? Yes, we do. But what is the purpose and why do we have to? Right. So why do we have to shut down the fire dampers? Exactly. So in a building, if you notice, you will have fire compartments. So there will be certain areas which are sensitive or which has got a more potential of fire, or maybe critical areas which the client want have important equipment, or maybe it's data, something which they want to protect. So those areas will be separated through a fire 2 hours fire compartment. So the fire should not spread from this protected area to outside, and likewise vice versa. Anything else actually? Is it just between the rooms, any fire compartments, or is there any other purpose? We will come to that. We are still at the MSDs and MSFDs. Yes, that is also one of them. We'll not talk about smoke management now. We are still in the general ventilation part. So, don't you think one a safe evacuation of the people, and the next one, I think, when the gentleman, sorry, I forgot his name, when he started off, he was talking about fire rated ducts and fire propagation, Safwan, sorry for that. So, the fire should not propagate, right? So, whenever you have the ducts crossing floors, you will see dampers, or from the branching which comes to a floor from the riser, you will have a damper. If that damper is open, obviously the fire is going to find a way through that. So that has to be closed. So the purpose of fire alarm system is to safely evacuate the people, and this also serves the same process. Next is the firefighting. Why do you think we will need an interface, and which items in the firefighting systems are interfaced with the fire alarm system? Pumps, yes. Fire suppression system, right, zone control valve. So let's go one by one. So why do you think a fire pump should be interfaced with the fire alarm system?
Fire pumps are there and electric pumps. Electric pumps are there. There's
Right.
diesel, sometimes it will get empty, then automatically it should.
Okay, but actually fire alarm system does not switch on the fire pumps. It just monitors it. Firefighting, the fire pumps actually operate on their own. They have their own controls, their pressure sensing. So based on that, it will switch on. But still, the fire system will monitor the fire pump, so that when the fire pump is running, it knows that there is something wrong, or there is an event in the building. So that's the reason it is interfaced. Someone said zone control valve, which we already talked about. Fire suppression system, someone said from the back. Why do you think a fire suppression system should be interfaced? No. I'm not asking about why do we need fire suppression system, but why the fire suppression system should talk to the fire alarm system.
To give the signal to activate the fire suppression system.
Actually, fire suppression system is self-sufficient. It can actually work on its own. It doesn't need fire alarm to give any signal for it to operate. It will operate on its own. It has got its own detectors. When those detectors activate, it will release the fire suppression agent. Okay. The primary function, as I said in the beginning, initiating devices. So we had detectors, manual call points, IFUs, other systems through IFUs was one of the points, right? So we said flow switch in the zone control valve that gives a signal. Fire suppression system, which I failed to mention then, but good that you brought it. So fire suppression system also activates when there is a fire in the room, right? So it means that some of the area has is into the fire already. So that has to be notified to the fire alarm system, so that the occupants in the building gets notified and they can safely evacuate from the building. So it is quite important that the fire suppression system is also talking to fire alarm system. And remember, when you are doing the design and rooms having fire suppression system, we don't generally give normal detectors. If you would have noticed, we just hatch the area or shade the area and will say that this room is actually protected by fire suppression system. You don't need to duplicate the detection again there. The fire suppression system does the job, and then it will notify the fire alarm system that there is a fire. Right. What is the next item? Right, air conditioning system. So which are all the items that or equipment or system that we interface with the fire alarm system as part of the air conditioning?
Actually, when the fire happens, all the electrical electricity is cut off, right? Then why we have to?
Actually, not. There is, if you see the fire alarm schematic or the design, we don't give any interface to any of the breakers to shut down the power supply. That is not because you are actually nailing your own feet. What if the fire pump doesn't start? Although you have a diesel fire pump, but there are multiple floors where
They have separate panel for that.
we do have, but why would you cut off one source of supply? You wouldn't, right? If you have two lives, obviously you will not give out one life, right? So power will not be cut off, right? So sorry, where were we? Air conditioning. So look, air conditioning system like the AHUs or again whatever is feeding to the fire will be cut off. Smoke ventilation. I think I should have kept it in a different order. Smoke ventilation is one of the most important thing. So why do you think we need to talk to the smoke ventilation system? What does it do? Right? So why do we have to clear the smoke? Why do we have to identify? Exactly. Again, we have to safely evacuate the people. So statistics says that people in fire affected building they don't actually die because of the fire burns. Most of the people die because of the smoke actually. So it is of paramount importance that you need to clear the smoke in all the escape routes. So that's the reason all the smoke extract fans will have to be notified that there is a fire on the floor, and it has to. So the specifically the notification will have to be going like this floor is on fire. So the smoke extract fan opens up, and then there are dampers for the particular floors. So those dampers will have to be again notified that this is the floor where it has to open the damper, and rest of the floors the damper should be closed, because I guess if I guess I'm right, the smoke fans will be designed to extract smoke from just one floor. It is not across multiple floors. It cannot handle that. So that's the reason it has to be interfaced, and a particular floor will have to be identified. Right, so gas is very straightforward, so it shouldn't be feeding the fire in the building. So the main gas valve to the building will be shut off. There will be an interface to that. BMS doesn't do anything after getting the fire alarm signal, but it has to be notified that it is only for the monitoring purpose. It needs to know that there is a fire actually. But there is actually anomaly in the design, I would say. Well, could be a bit of discrepancy also. So anything that is related to fire will have to be directly controlled by fire alarm system itself. But if you think through, I wish you would have done the stairwell pressurization. So stairwell pressurization system has got a VFD. So this VFD actually is controlled by BMS. Logically speaking, in case of fire, BMS is not actually trained, or it is not certified to handle the fire condition.
Pressure sensor, right?
Yes, how? How do you think the VFD gets the signal to ramp up or ramp down?
Are we doing that interface with the VFD?
Yes, so VFD has to get the signal, right? So that signal actually goes from BMS. The pressure sensor is talking to the BMS controller, and then the controller is actually sending the signal to the VFD to ramp up and ramp down. Which this is one thing which I am not very confident or very comfortable with. I would actually wanted a low power staircase pressurization fan so that the door could still be openable and it doesn't rely on any other system to operate the pressurization system. I think we are running out of time. Probably I will be available for some more time if there is anything more you guys wanted. Or can you just give me one last question to ask and then we will wind up? Right? Correct. So sorry for missing out that. Yes, good point to add. So garbage chute system will have to be interface. Gate barrier, yes, I thought that as part of access control. So just one question for everyone to, recap whatever we have learned. So the question to every one of you is, imagine you are standing in a building or probably a car park, I would say, and one of the sprinkler goes off. Can you think of the possible events which will follow after that? If you can actually put it in the right chrono, it will be much better, but any random answers will also be good. So based on whatever we have, discussed right now, I think this will properly sum up all those. Sorry, yes, that was right. Okay, so if I have to go to the right chrono, how would the smoke fans or the car park ventilation fans, I guess you meant that, will come to know that there is a fire there based on CO sensor? Is that CO sensor? I guess it will put that in the pollution mode, not in the fire mode. Okay. So even the CO sensor can trigger the fire mode, right? Okay, I stand corrected in that. But as you said, the first signal actually goes to the flow switch. Flow switch is the first point of action, so that gets notified to the fire alarm system. There is a fire in the parking. So the car park ventilation system, which could have been at the normal general ventilation mode or in the pollution mode, will now ramp up to the 10 air change mode. And then anything else? Fire pump will automatically switch on. That's when the water will start coming in and build the pressure. Access control, right? Yes, sound is. I think someone has switched it off already. Thank you. Or maybe the battery is gone. आ जाता है? All right, I think, look, if you, the slides will be with Samir. If you go through the interfaces section that we discussed, all the systems will actually start reacting to this. So if there is a fire somewhere, all the systems that we talked about will start reacting the way we discussed during the presentation. So with that, I think I've come to an end. There was one more, but I'm not going into that. So we will just close it at this point. And thank you very much to be a very good audience here. And thanks Samir and the entire MEP learning community to give me this opportunity to come before you. And anytime, anything, I'm approachable. My number is with Samir and I'm on LinkedIn. Anyone, please send me the request. I'll be humbly accepting it. And it's a pleasure to be here. Thank you.